Me, Said Ishfaq Noor, with the lecture Chemical Reactions with the subtopic Oxidation Reduction Reaction. Oxidation and reduction are the two types of chemical reactions that often work together. Both the processes, oxidation as well as reduction, involve an exchange of electrons between the reactants. For many students, there is always a confusion. The confusion occurs when we attempt to identify which reactants were reduced and which were oxidized, which reactant was reduced in a chemical reaction and which one was oxidized. What is the difference between the two? Let's try to find out. Oxidation occurs when a reactant loses electrons during the reaction. As you can see on the screen, oxidation is losing. Reduction occurs when a reactant gains electrons during the reaction. Reduction is gaining. This often occurs when metals are reacted with acids. These are mostly electrochemical reactions, acid-base reactions. When oxidation and reduction both they occur simultaneously in a chemical reaction, we call it as oxidation reduction reaction or redox. Reduction, rid and oxidation ox. So we call them as redox reactions. And on the right side, just move on to your screen. Oxidation reduction question. X loses electron and Y gains electron. Simple example of, let me take sodium chloride. Sodium loses electron and it is being gained by what? It is being gained by chlorine. So chlorine gains electron, chlorine becomes more negative, and X loses electron and X becomes more positive. So you can understand this question through that very example. So X being the reducing agent loses electron, Y being the oxidizing agent gains electron, X is oxidized by Y, Y is reduced by X. So simple example of NaCl can take us there. Moving on. Mnemonics to remember which reaction is oxidation and which is reduction. The first one you can remember is oil rig. Oxidation involves loss of electrons. Rig, reduction involves gain of electrons. Simply you have to remember, you have to memorize, students. Oil rig. Or second one is Leo says Gur. Leo is loin, lose electron in oxidation, gain electron in reduction. Let's take an example. See, when copper is heated in presence of oxygen, copper oxide is formed. So in this case, we see that oxygen is added to copper. Whenever oxygen is added to a particular substance, we call that reaction as oxidation reaction. So in this case, copper is getting oxidized. When we add oxygen to the copper, copper gets oxidized, and this is oxidation reaction. In another case, we add hydrogen to the copper oxide. Same reaction. When hydrogen is being added to the copper, oxygen is being removed simultaneously from the copper oxide. When oxygen is being removed, copper oxide gets reduced. This reaction is known as reduction reaction. So in a single reaction, both oxidation reduction reaction occurs simultaneously. We call it as redox reaction. Let's observe. Copper in its elemental state are neutral. So when the oxidation reduction process starts, copper loses electrons. So oxidation occurs, loss of electrons. You see, oxidation occurs and it becomes copper dipositive cation. And in case of oxygen, oxygen gains electron. So gaining of electron leads to reduction. So oxygen di-negative ion is formed. So this is the actual process of redox reaction. Let's take one more example. The reaction, you might be familiar with this reaction. Zinc metal, reaction of zinc metal with hydrochloric acid. You might have studied this in class 8 in case of properties of metals. So when we react zinc with when zinc is being reacted with hydrochloric acid, what happens in this reaction? You see, first the breakdown of reacting species takes place and the ion formation is being kick-started. As you can see in reaction number 2, zinc, chlorine and hydrogen ions are being formed. Let's first look see reaction number 3. Let's first look at what happens to the zinc atoms. Initially we have a neutral zinc atoms. As the reaction progresses, the zinc atoms loses 2 electrons to form zinc dipositive ions. That means zinc was oxidized into zinc positive ions. Second part of the reaction, fourth one, involves the hydrogen. The hydrogen ions are gaining electrons and binding together to form hydrogen gas. Right? The hydrogen ions gained an electron to form the neutrally charged hydrogen gas. The hydrogen ions are said to be reduced and the reaction is a reduction reaction. Since both the processes are going out at the same time, the initial reaction is oxidation followed by reduction reaction. This type of reaction we also call as redox reaction. But students, remember, as in case 1, in example 1, we saw oxygen helps us in the redox reaction. But in this case, despite the name oxygen need not be present in an oxidation reaction. So presence of oxygen is not must to carry out a redox reaction. Moving on. Electronation and de-electronation. So we say these are in these reactions where an element increases in its oxidation number charge, as seen as we discussed earlier. Sodium has oxidation number of 0, as do all the elements in their elemental form. So when this redox reaction starts, then Na positive, it loses ion and its oxidation number increases from 0 to +1. So some of the examples where there is addition and where there is gain and loss of electrons. Let's see, where conversion of ferrous to ferric, there is loss of 1 electron. Stannous to stannic, there is loss of 2 electrons. Manganate to permanganate, loss of 1 electron. Similarly, in case of reduction, we see conversion of mercurious ions. When there is gain of 2 electrons, they get converted into mercuric ion. When there is addition of 1 electron to a chlorine atom, it gets converted into a chloride ion. So here are some of the steps that are involved in writing an oxidation reduction equation by the ion electron method. Some of the steps that are involved, let me discuss. Number 1, first of all, we need to separate oxidizing and the reducing agents. Step number 2, let's jot down 1/2 equation for the oxidizing agent changing into its reduced form. Similarly, write down the other half of the equation showing the reduced agent changing into its oxidized form. Then comes balancing the atoms other than hydrogen and oxygen. Number 5 is the balancing the oxygen atom by adding water. Number 6, balancing the hydrogen atoms. Number 7, equalizing the charge on both sides. Number 8, this is important in case if the reaction proceeds in basic solution, we need to add enough hydroxide ions on both sides of the Hop reaction to get protons appearing there. Combination of these protons and hydroxide ions to give water and remove water duplication. Addition of 2 balanced half reaction. Let me try to understand this with the help of an example that I have that might be coming to your screen. How to balance an equation for the oxidation of ferrous to ferric ion by dichromate ion and acidic solution. The dichromate ion under these conditions yield chromium cation, tripositive ion. So for step number 1, just see on the screen, we write down the reactant and product of the half reaction for the oxidizing agent, changing into its reduced form, the dichromate ion into chromium cation, tripositive ion, right? Then followed by balancing the atoms other than oxygen, dichromate ion to this twice chromate ion. Then we followed by balancing the oxygen atom by adding 7 times water on the right. Number 4, balancing hydrogen atom by adding 14 H positive ions on the left. As you can see, step number 5, let me equalize the charge by adding 6 electrons on the left. These are the steps that are involved, as I discussed with you earlier. So for the other half reaction, write down the reactants and product of the half reaction for the reducing agent, changing into its oxidized form. Fe2 positive, Fe3 positive ions, equalizing the charge by adding 1 electron on the right. Step 2. So here we get equation 1 and equation 2. Adding these two half reactions, multiplying the half reaction 2 by 6 and adding the half reaction. Okay, so finally in this way we get this is the entire process for the conversion of ferrous to ferric ion. We get the chromate, this